These shots were taken from the helmet of a cyclist. One notices not only the bicycle's speed, but the smoothness of its ride. This new bicycle was designed by Alec Moulton. This film is about the innovative engineer's job.
Who was it was wanting one? The Bath Chronicle, did they get... Lovely bit of light now.
Alec Moulton is best known for designing the Mini suspension. When working on the Mini, he became interested in bicycles.
I bought a very lovely lightweight Hitchens bicycle and was amazed by how nice it was to ride. Remembering that the last time that I'd ridden a bicycle, I think, was when I was an undergraduate at Cambridge, and I had an old gridiron thing, because at that time I was naturally more interested in motorbikes. So I found how wonderful this modern lightweight thing was, how well it went and that. And being of a curious set of mind and an innovative set of mind, my thrust of interest was the architecture of the thing. Why is why are the wheels so large? Now, quite obviously, any schoolboy, as it were, would know, would understand or think, in fact wrongly so, the larger the wheel, the more easily it rolls. This was all first order, a bit of non-wisdom, if you like. So I did work on a fundamental basis of examining what is actually the mechanism of rolling resistance. And what came out, not surprising if you think of fundamentals, that the inflation pressure of the tire was the thing that really dominated the rolling resistance, and not the size at all. So we started with a wonderful, wonderful opening that we could reduce the size of the wheel, provided we had high-pressure tires. But of course, one would have to have suspension, because a small wheel would be more bumpy. So my concept, perfectly clear, was, and you can see it appearing in this bicycle here, which is our first one, small wheels, there, high-pressure tires, a suspension there front, and a suspension at the rear there. And that has been, if you like, the key, the fundamental key of all the Moulton bicycles, small wheels, high-pressure tires and suspension. But also, more importantly, the open frame. I regarded, in riding the classic bicycle, beautiful though it was, that I didn't like at all the presence of the top bar. The top tube, because that is necessary, of course, in conventional construction, but it's a bad thing because it makes it difficult to get on, it's anti-unisex, and in any form of incident, you are trapped on it.
The first Moulton bicycles, which appeared in the 1960s, were a major advance in bicycle design. They were as much a symbol of the 1960s as Mary Quant, miniskirts, or the cult TV series The Avengers. They were as successful on the racetrack as in the domestic market. But innovative engineering is about improvement, improving performance, efficiency and cost. So Alec Moulton went back to fundamental research.
So I made my study redoing the thing. Am I technically right with a concept of small wheels, high-pressure tires, and this frame? And we did some very nice work, quite original work, of measuring the power consumed by the rider at the same speed, classical bicycle, on ours. And ours was in fact 2 or 3% less power than the classical one, which is wonderful. We have felt that, but you always have got to go back to measure, measure, measure. Remember, nobody owns the laws of nature.
Although tests showed that the small wheel bicycle reduced the energy required of the rider, and that the suspension actually reduced the vibration suffered by the rider, it seemed clear that still further improvements to the suspension were possible. Alec Moulton is adamant that the crucial initial stages in any new engineering design are best done by the time-honoured method, sketching and drawing. Nothing must be allowed to impede the free flow of creative ideas.
That one, and then we're going to go cross parallel with that up there, somewhere like that. So we shall have a little piece sticking out. Quite how we're going to do that, I haven't quite decided. Of course, you're doing it at the other view.
Alec, like most designers, prefers to think on paper. Computers may be useful at later stages, but they can inhibit the free working of Although only ideas at this stage should all be carefully kept and dated. They represent the record of a thought process which a designer may have to revisit later. Although Alex Moulton had steadily evolved and improved the suspension of his bicycles since they first appeared, adding coil springs and a swinging arm at the front, by the early 1990s he felt driven to attempt further radical advance. But how does an innovative engineer set about achieving the kind of breakthrough advance that Moulton unveiled in his 1998 model? The rest of this film will explore some of the elements involved. At first sight, some of these may seem surprising. Steeping yourself in knowledge of earlier mechanisms and devices, for instance.
And it's very important for us to go and have a look at the past, not from the point of view of imitation, but for inspiration, and to see where things have come from. And I've particularly been concerned with suspension, particularly interested in this. This is a girder fork on a particularly good manifestation back in, let me see the date, 1930, racing Velocette, and it typifies the form of suspension which really came from the origin of motor bicycles, and very sensible. Let me just show you what the essential features are. Just examine that link with its mate on the back side and this link. So imagine that and that are a parallelogram or a system of linkage which are pivoted through there, so that there are in fact 8 pivoting points which demand lubrication. There's a lubrication, a grease point there. I can't see the one in there, but no doubt there is. And there's one lubricator here and another one there. And the linkage demands lubrication, otherwise it gets seized up. Now the springing is done by that coil spring, which you can see in there, going from there to there. And the damping, which is the restriction of the free movement of a spring, is done by a friction shock absorber there, which is adjusted, if I can move it, adjusted by that big unit there.
Having submerged yourself in the background to the problem, it is often surprising how quickly ideas start to emerge. Alex Moulton's notes reveal that within a few weeks he was on the threshold of a breakthrough.
Bonded rubber bushes to captivate a shaft. And here are these little sketches, proper little things done by my ink method on the squared paper. There and there and there and there, just that perfectly reasonable thing. And then suddenly, it's appearing as if by magic, in a way, something, just as one was sketching these particular rubber bushes or bearings, that thing was appearing, which is like my flexitor. And suddenly it came back to me, hey-ho, can't one therefore not only make a bearing, but also make the wretched thing do a springing?
Years earlier, Alex Moulton had designed a much larger suspension unit for use in a rough terrain motor vehicle, which he'd christened the flexitor. The Austin Gypsy had a short commercial life, but its flexitor suspension was proved sound.
In the flexitor, this is the outer shell, which is the outer shell there, down next to that. That is the inner shaft there, and that's the inner shaft there. And rubber sleeve is bonded both to the inner shaft and to the outer shell. And it is the twisting between the inner shaft and the rubber, between the inner shaft and the outer shell, which provides the springing, and making the analogy of doing it in that way there, so that imagining one sleeve, an arm was rubbery, that is the way the thing works. So it is the rubber being bonded between there and there. Which the problem is, how do you proportion a tiny thing like this? There's the flexitor, there's the flexitor, from the valuable data that you've gathered from the larger one, fatigue values and shear stress values. That can only be done by mathematical linkage, which is not difficult to do, but absolutely essential. Otherwise, one would be completely wasting one's time.
To help in such calculations, Alex Moulton keeps a small book of commonly needed formulae on his desk, which he uses throughout the design process. The sheets of engineering calculations that intersperse his design sketches demonstrate the fundamental importance of making relevant calculations at every stage. Executing clear and precise engineering drawings, fully dimensioned, is equally important so that your design can be made up in the workshop with the minimum delay. The innovative engineer must also be open to ideas coming from the workshop team. They will often be able to suggest improvements and more convenient ways of making things. Once made up in the workshop, each element in the design is tested. Here, the flexitors for the front suspension are being fatigue tested. Testing will in turn lead to further modification and improvement. Alec spends a lot of time exploring variations in dimensions and materials before arriving at the optimum solution.
Still aluminium.
Yes, that.
73.
Yes.
And then you said go to steel to get the extra.
Right, exactly. So that's obviously a very important point, that though it's a temptation to go to aluminium all the time, and that's got an advantage, if you like, you make the whole thing in one.
Yes.
The strength of it isn't much. So very soon we get back, don't we, Tim, to our friend the steel.
Steel tube.
To succeed, an innovative engineer should have a good working knowledge of tools and machinery. Good engineering is a hands-on job.
So I have a great affinity, if you like, a feeling of commonality with the making. Deeply need to know how things are made and respect the making of it. And I've got a deep desire for things to be made.
Having perfected each of the individual parts, the whole bicycle is now assembled and tested. Each part has to function properly in conjunction with all of the others. New problems may emerge when the design is tested as a whole. As well as testing in the engineer's own workshop, a new design will be subjected to independent testing. The new Moulton bicycle was sent to America for test.
Yeah, I got the bike in June, and since then I've done 1,100 miles, which is not a great mileage, but in the course of that, as you'd expect with the prototype, a number of things fell off and there have been a number of minor problems. The basic design has been excellent. It's really been a question of bits here and bits there. So we've been through a little bit of work with the fork. I got a different fork in the middle of the year. This is an update to the one that came with the bike, thus the different color. A bit of work on the drivetrain, a bit of work on the racks, some clearance problems. Really very little. We put a very large friend of mine on this long seat post to make sure there's no question that you could break the seat post over. And we put a very good spinner, a racer, who's the man who rode the Streamline bike years ago. And he spun it up to close to 200 RPM and went 50 miles an hour downhill, and no handling problems, and very smooth ride. In fact, he was all set to steal the...
It's beautifully soft, silky soft. No form of friction or wearing or maintenance or anything required in a totally unique system. And there are 4 of these, 1, 2, 3, 4. And, thank you for that. And the top one here also has a cutting device. That little hand adjustment there controls the amount of damping. Now, I've turned it back, and you see that it is no form of damping or friction. Now, if I just, as I can do this riding along, there it's beginning to, there, that's beginning to become, it wants running in so it won't make that little squeak, but it's beginning to produce some damping. So that's that feature. Another element, which is a thing which is very, very subtle, it eliminates high-frequency vibration. If you're a violent rider and wants to check the movement of the bicycle so that you can almost lock it out, one does this. It's unlocked, and then riding it, obviously one does when riding it, you flick that back there, like that, and it is effectively locked. It's got still a tiny amount of it. Then on the rear suspension, that's the front, tiny little unit there, moves in this way. You can see how beautifully it moves. Soft as can be, and completely damped. It's got fluid damping inside it, which is adjustable by this little... Oh, it's there, that's the one, that's the little valve under that thing. You could adjust the amount of damping by there. You could also, for weight, heavy weight, you could put air in there, which inflates the backside of the thing, for increasing the stiffness of it for heavier weights. And the little unit itself is that tiny, tiny thing. That little spring there, rubber to metal bonded, made in the workshop, here contains fluid inside, adjustable damping there, and air. Ordinary pressure from a bicycle pump goes in there. So that's a total innovation.
Innovative engineers create new products, not just paper designs. If it is to succeed, a new product has to be suited to manufacture, as well as working properly in the field. The novel suspension system, rubber bushes replacing springs and bearings, is fundamentally simple to make, a most valuable feature when launching a successful new product. The new product now faces one further test, the most severe of all. The success or failure of all the innovative engineers' work will depend on it. Will customers buy the product?
But it's frictionless, and so also no service. So there's nothing it wears. There's no bearings.
Exactly the specification to suit a particular market, but this thing is the jewel in the crown.
Create a concept by sketching. Most designers prefer to think on paper, with as little impediment to imagination as possible. Calculations are essential. Alec Moulton used data from the larger 4x4 vehicle suspension to calculate the dimensions of his bicycle suspension. Determining these dimensions from scratch by experiment would have been lengthy and expensive. Computers may constrain concepts. Computers are very useful to the designer, though their features and application may limit the designer's creativity. Understand engineering materials. Do you recall that Alec Moulton selected rubber against steel for the springing of the suspension, and steel against aluminium for its structure? Design for manufacture. Innovative engineers create products that can be made to cost targets. A paper design that can't be made has little value. Thorough testing matters. Products must work properly. Do you recall how thoroughly Alec Moulton's bicycle and its suspension were tested in the workshop? Field trials are important. No matter how well the design functions in the factory, thorough testing in the field is needed to confirm that the product works as intended.